So what I see first in this table is that there are consecutive x values, and I can see every single time my y value, my dependent variable, is twice as great as the previous. So I know that this is my constant multiplier, which is awesome. Now to get back to the starting value, you talked about all of this today, that you'd have to divide by 2 to move back. So what I want you to think about here is that I know I'm going to use this as my starting value, which is 30. And my constant multiplier is 2 to the x. But I'd have to divide it by 2 how many times to get back to a starting value of 0? So I'd have to divide it by, to get to the 2, to get to the 1, to get to the 0. I'd have to divide it once, divide it twice, divide it by 3 times. So I'd have to divide it by 2 to the third, just because I divided once, twice, 3 times, otherwise known as 2 to the third. And what you have found today with Ms. Horn is another way to think about this, that when you see this, you also could write this as 30 times 2 to the x minus 3. And these are exactly the same thing. So, oops, sorry, I missed that one. But that this over 2 to the third is the same thing as 2 to the negative third. I'm going to give another example just in case. Here's another one where we can see, again, the constant multiplier pretty nicely every single time. I'm multiplying by a half to get from one stage to the next, because all of these are in consecutive order. So I know that my constant multiplier is 1/2, so I know it's going to be y equals, so I have 1/2 to the x. And I'm going to just say that my starting value is here, is at -2, I'm at 8, so my starting value is 8. What would I have to do to get to my starting value with a y-intercept? And so what I would do is I would say here I'm at -1 and then 0. I'd have 2 steps. What would I have to keep doing? I'd have to multiply by a half and multiply by a half. So I'd have to multiply by 1/2 to the second power. And so another way that you talked about this today in class, that you could write this same equation, is that you would say this is the same thing as y equals 8 times 1/2 to the x plus 2 power. So some of you may, it sounds like from what Ms. Horn has said, is that you would really like to just think about this as the x plus 2 or x minus 2. I just want you to see that if you either don't like that or you want to think about a little bit more where it came from, is that this here, when you're multiplying again by a half and by a half, this with this ends up then playing the same role as this.